So, good afternoon. First year BSc Data Science, Data Science. So, statistics class. Today we continue with last class, that is graphs, different types of graphs used in statistics. So, we start the PPT. So next we discuss about scatter plot or scatter graph. So what is a scatter graph? So when each entry in one data set corresponds to an entry in another data set, the sets are called as paired data sets. In a scatter plot, the ordered pairs are graphed as points in a coordinate plane. The scatter plot is used to show the relationship between the two quantitative variables. The following scatter graph represents the relationship between the number of absences from a class during the semester and the final grade. So, scatter graph is mainly, or a scatter plot or a scatter graph is mainly used to pair, used with ordered pairs as points, represented as points in a coordinate plane. So this is the simple example of a scatter plot. Scatter plots are generally used with some dots, represented by dot symbols. So in x-axis we may take the data values, whereas in y-axis we may take another, it is also some data value, not the range values. So from the scatter plot you can see that the number of absences increases, the final grade tends to decrease. So in x-axis and y-axis we may take two numeric values, and each dot is represented with the corresponding value of the, or corresponding coordinate values of the x and y. So the first dot represents the coordination of point x, that is 8, and y at 78. So here we observe that the number of absences are increases with the final grade tends to decrease. So this is the scatter plot. Scatter means we are using some dot symbols. Simply we are using some dot symbols. Next is a time series chart. Another type of graph in statistics to represent data information is time series. A data set that is composed of quantitative data entries taken as regular intervals over a period of time is called as a time series. A time series chart is used to graph a time series. Example, the following table lists the number of minutes a robot used on his cell phone for the last 6 months. Construct a time series chart for the number of minutes used. So what is a time series chart? What is a time series and when it is used? It is used means generally a time series chart is composed of quantitative data entries taken at regular intervals over a period of time. So whenever we take time considerations, whenever we take we are using time as a data element, in that case we may use time series chart. So this is the example, month and minutes. Here month is January, for the 6 months January to June, and minutes generally in seconds or minutes. So time series means it is also called as a line chart by simply connected with a single dot with each dot with another dot. So in this case we may, in x-axis we may take month as months, whereas in y-axis we may take months or minutes, generally in numeric values. So this is the example for using a time series chart. So next concept is all this comes under first unit only. So next we discuss about measures of central tendency. Measures of central tendency means how to measure or how to use various charts or graphs or data with the central tendency means taking a center point of a class. So taking center point of a class, we may use various techniques and methods. So what there are three important concepts. First one is mean, median and mode. Mean, median and mode. So what is mean, median and mode? The following are the ages of all 7 employees of a small company. So 53, 32, 61, 57, 38, 44 and 57. Calculate the population mean. So what is mean? Mean mu is equals to sigma x by capital N, where capital N is the number of data elements, that is 7 elements are 7 samples are taken. Small x is individual element. Sigma x means sum of the all the elements. So what is the mean? Mean is equals to mu is equals to sigma x by capital N, that is 343 by 7. Add the ages and divided by 7, that is 49 years. So the mean age of the employees is 49. What is the mean? Mean means it is the central point. It is the central point of the data, sample data, given sample data or given data or information. So what is mean? Mean means the sum of the total data elements by number of data elements. So this is the example. The following are the ages of all 7 employees of a small company. Calculate the population mean. Mu is equals to mean is equals to sigma x by capital N. What is x? X is single data element or a single data. By capital N means total number of elements. So sigma x by N means 343 by 7, that is 49 years. So add the ages and divided by 7. The mean age of the employees is 49 years. So next is median. What is median? The median of a data set is a value that lies in the middle of the data when the data set is ordered. If the data set has an odd number of entries, the median is the middle of data entry. If the data set has an even number of entries, the median is the mean of the two middle data entries. So what is the mean? Mean means generally the central point of the data items, where generally the items when you calculate the median, the data item should be in ascending order, either in ascending order or in descending order, should be arranged in ascending or descending order. So if the number of items are even, the mean is in between the middle of two numbers, whereas if the number of items are odd, the mean is the middle value of the given data items. So calculate the median of the 7 employees: 53, 32, 61, 57, 39, 44, 57. So to find out the median, sort the data in either in ascending order or in descending order. That is 32, 39, 44, 53, 57, 57 and 61. So here the number of items are odd, so that the median is 53. So median age of the employees is 53 years. So mode, the third formula is mode. The mode of a data set is the data entry that occurs when the greatest frequency. If no entry is repeated, the data set has no mode. If two entries occur with the same greatest frequency, each entity is a mode and the data set is called as bimodal. So what is a mode? So find out the mode of the given following ages of an employee: 53, 32, 61, 57, 39, 44, 57. So an outlier is a data entry that is far removed from the other entries in the set. So what is a mode? Mode of the data is simply nothing but that occurs with the greatest frequency. If no entry is repeated, means if there are no repeated values in the given set of data or data items, there is no value for the mode. And if the number of items are repeated, So what is the mode? Mode is considered as the maximum number of data items repeated. What is the mode? Mode is nothing but it is the maximum number of data items repeated in a given set of numbers or data or information. So comparing the mean, median and mode. So all these three are generally used to find out the center point of a data or central tendency. It is also called as to find out the central tendency of the given data items. So a 29-year-old employee joins the company and the ages of the employees are now 53, 32, 61, 57, 39, 44, 57 and 29. Recalculate the mean, median and mode. Which measure of central tendency was affected when this new age was added? So what is mean? Mean is equals to 46.5. The mean taken every value into account, but it is affected by the outlier. Median means 48.5. The median and mode are not influenced by extreme values. Mode is 57. So what is mean? Mean is 46.5 and median is 48.5 and mode is 57. So weighted mode. Next is weighted mode. What is weighted mode? So next is weighted mean. What is a weighted mean? So a weighted mean is the mean of a data set whose entries have varying weights. Weighted mean is given by x bar is equals to sigma x into w by sigma w. What is the weighted mean? Formula for weighted mean: x bar is equals to sigma x into w by sigma w, where w is the weight of each entry x. So for example, grades in statistics class are weighted as follows. Tests are worth 50% of the grade, homework is worth is that 30% of the grade, and the final is 20% of the grade. So a student receives a total of 80 points on tests, 100 points on homework and 85 points on his final. What is his grade? So how to find out weighted mean? So begin by organizing the data in a table. So source x, score x, weight w and x into w. So tests, homework and final. Test means 80 marks, homework is 100 marks and final is 85 marks. So weight w. What is the weight? So weight is 0.50, 0.30 and 0.20, and x into w means 40, 30, 70. So x bar is equals to sigma x into w by sigma w, that is 87 by 100, that is 0.87. The student's current grade is 87%. So next is mean of a frequency distribution. So how to find out a mean of a frequency distribution? So the mean of a frequency distribution for a sample is approximated by x bar is equals to sigma x into f by n, where n is the total number of items, x is the data and f is the frequency. X bar is the mean of the frequency. So note that n is equals to sigma f. And what is n? N is equals to sigma f, where x and f are the midpoints and frequencies of the class. So this is the example. The following frequency distribution represents the ages of 30 students in a statistics class. Find the mean of the frequency distribution. So class, this is the frequency distribution table. Class intervals x, f and xf. Class interval is 18 to 25, 26 to 33, like that. X is equals to, what is x? X means class midpoint. Class midpoint is lower limit plus upper limit by 2. that is 21.5, 29.5, like that. F is frequency. Frequency means a number of data items falls in that category. X into F, X into F means like that. So n is equals to, what is n? N is equal to sigma F, that is sum of all the frequencies, that is 30, and sigma xf is equals to 909.0. So what is the mean of a frequency distribution? X bar is equals to sigma x into F by n. So 909 by 30, that is equals to 30.3. So the mean age of the students is 30.3 years. So next is measures of variation. Next topic is measures of variation. So how to measure the variations in the data or data frequencies, like that. So here we may use different terms like range, deviation, variance and standard deviation, like that. So we start with ranges. So what is the concept? The concept is how to measure the variations in a statistical problem, or how to measure the variations of a statistical problem. So first one is a range. What is a range? The range of a data set is the difference between the maximum and minimum data entries in the set. So range is equals to maximum data entry or data value minus minimum data value. So example, the following data are the closing prices for a certain stock on 10 successive Fridays. So find the range. So stock is 56, 56, 57, 58, 61, 63, 63, 67, 67, like that. So in this range, the minimum value is 56 and the maximum value is 67. So the range is maximum value minus minimum value, that is 67 minus 56, that is 11. So what is the range of a data? Range is nothing but it is the difference between the maximum and minimum values in the data items. Next is deviation. So next is deviation. What is a deviation? How to find out deviation? So the deviation of an entry x in a population data set is the difference between the entry and the mean mu of the data set. So deviation is equals to, deviation of x is equals to x minus mean or x minus mu, where mu is the mean of the data set. So example, the following data are the closing prices for a certain stock on 5 successive Fridays. Find the deviation of each price. So stock x 56, 58, 61, 63 and 67. So sigma x is equals to 305. So mean is equals to sigma x by 5, that is equals to 61. So deviation is calculated for each and every item of a data set or data. So stock or data item is x. So deviation is equals to x minus mu, where mu is the mean of the data set or data items. So 56 minus 61 minus 5, 58 minus 61 minus 3, 61 minus 61 0, 63 minus 61 2, 67 minus 61 is equal to 6. So sigma x minus mu is equals to 0. So the deviation is 0. So the mean is 61. So variance and standard deviation. So what is variance? And so the first term we learned is range, second term is deviation, third term is variance and standard deviation. So what is variance? The population variance or variance of a population data set of n entries is population variance. Sigma square is equals to sigma squared is equals to sigma x minus mu whole square by capital N, where x is the data item, mu is the mean of the data item, sigma means sum of the data item x minus mu, where capital N is the total number of items or n entries in a data set. So the population standard deviation of a population data set of n entries is square root of the population variance. So standard deviation sigma is equals to square root of sigma square, that is square root of sigma x minus mu whole square by capital N. So capital sigma is called as standard deviation. So sigma is called as standard deviation, that is square root of sigma square, that is square root of sigma x minus sum of x minus mu whole square by capital N. Where sigma square is equals to variance. Variance is called as sigma square. Sigma square is equals to sigma x minus mu whole square by capital N. So finding how to find the population standard deviation. So first step, find the mean of the population of data set, that is equal mean is equals to sigma x by capital N. So in the first step we have to find out the mean of a data set, that is mean is equals to sigma x by capital N. Second one is find the deviation of each entry. Deviation means x minus mu. Deviation means x minus mu. What is x? X is the data item, data minus mu is the mean. Third step is square each deviation, that is we have to find out the x minus mu whole square. Fourth step is add to get the sum of squares, that is sx is equals to sigma of x minus mu whole square, means we have to find out or add all the values of x minus mu whole squares. In the fifth step, divide by capital N to get the variance, that is variance is sigma square. Sigma square is equals to sum of x minus mu whole square by capital N. Find the square root of the variance to get the population standard deviation. So standard deviation is equals to square root of sigma x minus mu whole square by capital N. So how this is the formula to find out. These are the steps. These are the steps to be followed to find out the standard deviation of a data set or a data item. So finding sample standard deviation. This is population standard deviation and finding sample standard deviation. So this is the example, finding the population of standard deviation. So we may continue in the next class.